Welcome back. So hope you have tried or attempted to solve the question. So we'll be now solving this question for last video. So this is a continuation. Now, the first thing, since we have been given the m:1 ratio, the first task is the one which we will be finding the number of carbon atoms. So that is just a simple one, which is 100 is divided by 1.1 times 0.6, which is m+1 over m, which is 0.66 divided by 14.5. That should give us an approximate value of 4. Okay, that means this is actually what? This is the value of our x. So our x is 4. We got the number of carbon here, which is 4. We know the oxygen number is 2. Okay, we need to find the hydrogen number here, like the number of hydrogen there, or the value of y. So let's see, we are having 3 chemical environments here. Okay, and each of the hydrogen number is given, like for which group we are presenting. Let's say if this is a carbon we are talking about, the adjacent carbon has how many hydrogen? Based on the number of peaks, this is number 3, like number of peaks as 3. So we know n+1 is equals to 3 in this case. So n is what? The number of hydrogen, which is 2. I mean, the adjacent carbon must have 2 hydrogen. However, the carbon we are talking about, this should have how many hydrogen? 3 hydrogen. That means this is so far is the scenario. Moving on to the next environment, here we can see we are getting here a like single peak here. But about whom we are talking, that carbon, like if this is the carbon we are talking about, like whatever it is, even if it is an, let's say, since there's an oxygen, we can assume that there's an alcohol. But even if that is the case, that carbon should have how many hydrogen? It should have 3 hydrogen present. So if there's a 3 hydrogen present, and it's the alcohol, then this as a whole should be the structure. But we need 4 carbon bonded with each other. So this cannot be the situation, or this cannot be the case. If this cannot be the case, then what could it be? So let's observe from the nearby values present here, or the other groups present here. See, here we have, since there is a like 2 oxygen here, a possibility is that like either there could be 2 alcohol, that could be a possibility, or there could be a presence of let's say few things could be here. One is it could be an ester, it could be an carboxylic acid, this could be an alcohol, this could be aldehydes, this could be ketone. So if this is an aldehyde, then there should be 2 oxygen, and that means 2 aldehyde groups should be present. If this is a ketone, there should be 2 ketone groups present. If there's an alcohol, then 2 alcohol groups should be present. But if this is a carboxylic acid or an ester, then there's a possibility just 1 carboxylic acid and one ester could be present. Let's try with the easier one, which is carboxylic acid or ester in this case. Okay, let's try with that one. So a possibility could be a carboxylic acid. This is, if that's the case, then this is a carboxylic acid, like just the normal one. And there are a few possible carboxylic acid present here, which is, let's say, is there any such? There could be a branching present here. So this could be a scenario. Wait. Yeah, so this is basically what I'm talking about. So this is a carboxylic acid. Okay. Is there, like, how many environments are there? Let's see. This is environment. This is another 2 environment which are unique to each other, and that's a different environment. So in total 3 environment. Yes, we have 3 environments. This might be a possibility, but still we have ester left with us. But see, let's see about this carboxylic acid. Here we have 1 environment, here another, and here another. So in total 4 environments. So this is not possible. Okay, this carboxylic acid is not possible. Let's see the other pattern. We can have the same carboxylic acid here. Okay, but in this case, no, this is the same as this one. Okay, so like drawing it here, this is the same as, because if we count the largest number of carbon chain. So this is the carbon chain you can go talk about, which could be actually this one. Okay, so either way, like they are same. If we like since this is bent here, if you don't give the bent here, what could it be? Let's say this is just rotating 90 degree to this one. So this could also be like written as this one, isn't it? Just think it in this way. Wait. Think it in this way. Let's say this carbon, we could just draw it simply over here, isn't it? This and this is like they're the same thing. So yeah, like nothing's different there. Now, what we're left with is an ester. What we're left with is an ester. So let's talk about an ester. Let's say the most like easiest one or the most common one. So this is one of them. Then there could be a possible, just I'm first drawing all of the possible esters. Okay, this could be an ester. Yeah. Is anything else? Finally, this could be an ester as well. Okay, these three possible esters are there. I hope no other esters are possible. Yeah, another one is possible, but that's just like forming a group here. I mean, forming a branch here. Just simply having a CH over here, and that's basically it. Let's see if there is a possibility in this way. Here, for this ester, we have one chemical environment, two chemical environment, third chemical environment. Yes, that's also possible. For these, 1, 2, and 3, yes, that's also possible. 3 chemical environment. For those, 1, 2, 3, and 4. 4 chemical environment, not possible. This one is not possible. This one, there's this 2 common scenario. Just a second. It got hanged. So here we have a common, I mean the unique 2 group are present here. So that as a whole is one environment, the second and third environment. So these are the possibilities. These like 3 esters are possible, 1 carboxylic acid are possible. But now let's see what is the information we have been given. We need a CH3 and a CH2 group. We need a CH3 and a CH2 group. We have a CH3 group here. Let's say in all the cases we have CH3 group here present. Okay, and the adjacent carbon, like this CH3's adjacent carbon should have a CH2. That means this as a whole should be present there. This as a whole should be present there. And this is not possible because we don't have CH3 bonded with CH2. There is no CH2. That means this is not possible. Here we have CH3 bonded with no CH2s. No CH2 is there. Okay, adjacent carbon does not have a CH2. So this is also not possible. So these are the 2 possibilities. Okay, now from these two, let's see which one of them are ideally correct. Let's see. Now, whatever the information is given here, we have a singlet there. Now, talking about the singlet, that means that just like the carbon we're talking about, its adjacent carbon should have like 0 hydrogen. Like let's say for this one, about this one, okay, about this one, the adjacent carbon should have 0 hydrogen. In that case, we will be able to produce what? We'll be able to produce n plus 1, which is 0 plus 1 equals to 1 peak. And the carbon we're talking about, that should be having a 3 hydrogen carbon. That means this is the CH3 we're talking about, the 3 hydrogen carbon. And the adjacent carbon should not have any hydrogen. Okay. If that's the case, then in which of the region or in which of the place we are getting? One possibility is this one. Talking about a possibility here, not I'm exactly sure, but possibility. Another could be possible, you can say this one, but see this CH3 does not have any environment, like it does not have any adjacent carbon. If it does not have any adjacent carbon, that means there is so far no adjacent carbon. I mean, like it's a bit complex to like I identify, but still, like we have CH3 group here, and each of them we can say that singlet is we're talking about, but this is much more preferable because since it has adjacent carbon with no hydrogen, but it does not have adjacent carbon with no hydrogen. Okay, you can say what about this one? But this does not have a CH3, and the adjacent carbon, like this is not a CH3, and the adjacent carbon, like I mean this one, which does not have any hydrogen, its adjacent carbon does not have any CH3. So that's what I'm talking about. Let's see what more information can we gather. You know what? Let's go back to the data booklet to see actually what we have been talking, like what we have been talking about. We are being left with the ester, only ester. No more alcohol. I mean, no more carboxylic acid as we're talking about. We're just simply dealing with ester. Also, see, carboxylic acid is in the region of what? 9 to 1.3. And if you come back to our graph, none of the reading is like in the region of 9 to 13. That means it is at nowhere a carboxylic acid. This must be an ester. Okay, if this is an ester, so we are so far doing correct. That means this is an ester. We should have C double bond O group or an ester group, you can say, whichever it is. Let's see, do we have an ester group? Ester. So what we can see or observe that ester itself does not exist, but we can talk about the esters double bond. Okay, that means C double bond. Like this group, it does not have any environment. This is because simply think here we have no hydrogen present, isn't it? In this region, we don't have any hydrogen present. So we cannot talk about this as a unique group. However, what we can talk about is just a minute. What we can talk about is if this CO is bonded with some CH3 or CH2. At the same time, if this oxygen is bonded with the carbon, we can talk about that as well. Why? See here, this is what it is talking about, CH2O, CH3O. That's what I was talking about. This single oxygen could be bonded with that sort of molecule. And this double bond of oxygen could be bonded with some CH3 or some CH2 group. Okay. So this is in the region, like this double bond is in the region of like double bond O, or oxygen double bonded with carbon is in the region of 2.2 to 3. And we do have a region in that, like we do have a substance in that region. Let's see, this is the substance. So that means this should be some C double bond O group bonded with some, let's say, CH3 or CH2. However, what about this one? Let's see. Let's go back to the data booklet and try to observe, are we true so far? In the region of, yes, we got one. In the region of this 3.2 to 4, we have CH3O or CH2O. Okay, that means we need a oxygen, just a single oxygen bonded with the carbon. So this is that which I'm talking about. So this is actually, you can say C1 like bonded with one oxygen. There could be other bonds, and here should be some CH3 or CH2. There should be CH3 or CH2. Okay, so now let's see, are we so far correct? Remember, like I think you can actually get the gist what I'm talking about. This oxygen is the carboxylic acid part. Like in the ester, this is about the region of the carboxylic acid. Okay, see over here. Both the cases, we have a C double bond O. So this is one such group we can talk about, and this is another such group we can talk about. Similarly, over here, this is one such group we can talk about. This is another we can talk about. Okay. In both the cases, like this is the region whose adjacent carbon has how many hydrogen? 3. That means 3 plus 1 is what? Equals to 4. That means that's a quartet. However, this CH3C double bond O, this does not have any adjacent carbon. That means it has a group of what? 0 plus 1, which is a singlet. That's the possibility. And this is in the region of what? This is in the region of 2, isn't it? This is in the region of 2, like in the second group. Like so far we can find like this one or this one, both should be in the region of what? Because C double bond O here, C double bond O is in the region of what? In the 2, like the reading of 2. So either a quartet or a singlet should be in the region of 2. Let's see above. See here the singlet. That means what? That means the carbon we're talking about, it should be having 3 hydrogen with it, yes. And the adjacent carbon, or at the adjacent carbon, there should be no hydrogen. Since the adjacent of this carbon, there is no other carbon present. That means what? Obviously, there should be 0 hydrogen. Yes, this is so far true. However, let's talk about this one. This has what? A three, like the adjacent carbon has three hydrogen, that means four. That means a quartet should be there, but there is no quartet in the region of two. So that means this is not possible. But still, so far, let's go on. Let's move on to the next part, which is this one. It says they should have a CH2O group. So CH2O group, let's see over here, which one represents CH2O group? We can observe from here, we have a CH2O group here, which could be a possibility. And this is a CH2O group, but we need the adjacent carbon should have or should be bonded with 3 hydrogen so that we can get a quartet. In this case, we have a 3 hydrogen. That means a quartet is there because 3 plus 1 is 4. That's why we should get a quartet in this case. See, there we have a quartet. 4 peaks are there. However, the carbon we're talking about, does it have 2 hydrogen? See, here we don't have 2 hydrogen, we have 3 hydrogen here. But here we do have 3 hydrogen here, like the carbon we're talking about. That means in that structure, which they have said that this is the region we are talking about, the carbon should have 2 hydrogen. That means this carbon, which is bonded with a single oxygen, should have 2 hydrogen, and its adjacent carbon should have what? 3 hydrogen, because we should get a quartet. So there's the quartet. Similarly, the carbon we're talking about, or the group we're talking about here, this should be a group having a C double bond O group, and there should be the component which should be bonded with itself is a CH3, which is we're talking about the 3 hydrogen carbon. So this is the group we're talking about, and its adjacent should have no carbon group. So that means this is a situation. At the same time, see over here, we have a triplet here. That means what? We're talking about the carbon group which should have 3 hydrogen, and its adjacent carbon should have 2 hydrogen, so that we can get a triplet here. And here, yeah, 3 hydrogen, triplet. Okay, so that means there's the possibility that, or so far we got our information based on the data provided, that this is actually our result. Okay, so that means, just a minute. So this should be our component actually. So this is our result, final result. Hence, just a minute. It sort of sometimes does not work. It gets like hanged here. So yeah, so this is the component we are talking about. So finally, we have this 4 carbon group, 1, 2, 3, 4, and we have 1, 2, 3, 4, 5, 6, 7, 8. So a hydrogen is the Y value should be what? The value of Y should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that means our final group is C4H8O2. That's an ester. So I hope you will be now able to answer for which group, which value actually represents. In this region, this is for whom? This is for the CH3 group. Okay, this reading is for the CH3 group, which is on the alcohol side. Okay, on the alcohol side, like this one, which is on the alcohol side of the ester. You're talking about that. This one is for which one? This one is for the C double bond O CH3 group. Okay, which is on the esters, like the carboxylic acid part. And finally, we have this quartet, which is in the region of this. I mean, this is the region we are talking about. So that's basically CH2O group. Okay, so that's the region we're talking about. Now, moving on to our next example. Okay, so the next example, just a minute, let's see. Okay. Yeah. We're given again a CXHY, but this time oxygen is undefined. And we have, let's say, 0, 1, 2, 3, 4, 5, 6, 7, and 8, and it goes on. Okay, I'm not drawing all of them. Now, some interesting thing here, we have just a singlet. Yeah, we have another singlet. Here we have another singlet. Okay, m is to m plus 1 is given here as 25:2. And anything else? No. So these are the information being given to you. Now your duty is to find the result here. So try to attempt it by yourself. If you can't solve it, I would urge you to pause the video here. We'll be solving it together. Otherwise, like, try to solve it at first. If you can't, we'll be solving it together. So if you couldn't solve it, let's try it together. See here, we have what? You can see we have 3 chemical environments. And now see one thing. None of the groups are present in this region. Okay, none of them are given here in this region, in the region of 0.9 to 1.7, nor even 2 or 3. Like, we can so far say that there is no such CH3 or CH2. Like, so far we can assume, but that's some other thing to be concerned about. That's at first fine. How many carbon atoms are here present? C equals to what? 100 over 1.1 times 25. Is it 25? Oh no, it's 2 over 25, because there should be reverse. So 2 over 25. So that should give us a value of 7.3, which is approximately 7. Okay, now see how many carbon do we have? 7, isn't it? One thing you should be concerned that usually, okay, this is not always, but usually in such situation where we have, let's say, similar sort of thing, and the number of carbon is greater than 6. So if number of C is greater than 6, usually they talk about benzene. Okay, this information will help you immensely in many situations, because you don't have to work extra hard in this situation. So we are concerned about the benzene ring only. So we know the value of X here. So X is what? X is 7. So far we got it. We need to find hydrogen and oxygen value here. Let's see our data booklet in this case. Let's go to our data booklet and see what information do we have about benzene. Now about benzene, what structures do we have? One is over here. Okay, so this is one benzene structure, then another is this one, and another is this one. But this shouldn't be the case. Why? Because remember, we don't have a nitrogen here, so this is not possible. So let me draw with a red color. That means this is a possibility. This is a possibility. Anything else? No, nothing else. So that means either phenol or like this simple benzene is there. But we know there should be oxygen there as well, because O is given. Like, they have mentioned oxygen should be there because we need to find the value of Z as well. So if that's the case, that means there should be benzene. But we also have to see which one represents what. Now, think it in this way. Let me go back to the blackboard. They're talking about this region. Okay, before coming to this portion, let's go back to the data booklet first. Now take the values. This is in the region 6 to 9, and this is from 4.5 to 7. 6 to 9, 4.5 to 7, 6 to 9, 4.5 to 7. Okay, so just a single H in the benzene ring, that is for 6 to 7 and 6 to 7, sorry, 6 to 9. 6 to 9, and if it has a phenol OH, that is in the region of 4.5 to 7. Okay, 4.5 to 7. Yeah. Now, what do we have? Let's see. 6 to 9. That means this is the region of 6 to 9, and in this region, if that's the case, that should be our simple benzene ring. That means there's the benzene ring present, and that benzene ring, like just talking about that simple benzene ring, that benzene ring should have 4 hydrogen. It is talking about. That means there should be 4 hydrogen there. That means 2 other groups should be there that shouldn't have the hydrogen. Rather, some other group should also be attached to it. One is given hint here, which is in between 4.5 to 7, which is 4.5 to 7. Here we have just one such portion. That means this is representing which group? Can you guess? Obviously, like, you can say hydrogen is there, but I would go for OH group. Why? Because remember the why? Because 4.5 to 7, that represents what? The phenol, OH group. So we can say that our benzene, one of the group is what? OH. That's what we found in the region of 4.5 to 7, and it suggests that there's one hydrogen in that group. So yes, one hydrogen, fine. Another thing they're saying that there should be some group which has 3 hydrogen. Now what group should be present there to have 3 hydrogen? Can you guess? Now you might say, what about a CH3 group? Like CH3 group could be a possibility here. But see, if CH3 group is there, then CH3 group is present here. What is a possibility? Let's think. Is there a possibility that there could be a CH3 group directly coming here? Oh, I forgot. We must have what? How many carbon here? I forgot about this value. So obviously we should have 6 hydrogen from the benzene ring, but we should have 1 more carbon. So yeah, 1 more carbon is there. A carbon is here, but should it be a CH3 or something else? Now talking about that, what group could be? Oh yeah, one thing we forgot to take. Which value represents in this region? 3 to 4, having 3 hydrogen, 3 oxygen, isn't it? Now going back to, sorry, having 3 hydrogen. Now going back to our data booklet, what do we have? Here, C3.2 to 4, we have a group which is CH3O. So CH3O group is here present. Okay, so CH3O group is present there. So if that's the case, then CH3O should give us a value of what? The CH3, like this should be a possibility. That means our group should be OCH3. Okay, this should be a possibility. Why? Because see, observe here, if this is not the case, if this is like there's a direct CH3 here, that direct CH3 should be like in this region, isn't it? Like in this region should be the CH3. Why? Just observe from the data booklet, there's no such group where CH3 benzene is mentioned. See, CH3 benzene is not mentioned. If CH3 benzene is not mentioned, then we have to stick with this value, like this CH3. But since this is not the case, like we don't have any reading in 0.9 to 1.7, that means one possibility is like this one, from 3.2 to 4.0. And since it has a singlet, that means what? The adjacent carbon, I mean, like there is no adjacent carbon. I mean, the adjacent carbon on the environment itself is a singlet, since the adjacent carbon does not have any hydrogen. So the possibility is what? This molecule, which is 1, 2, 3, 4, 5, 6. So this is OH, and there's a OCH3. There could be you can place it here, or you can also place it, let's say, like over here. But remember, either second, fourth, or sixth group. Okay, OCH3. Okay, like from phenol, there should be either in the second group or the fourth group or the sixth group. Anyone could be. Okay. Now, which are the readings we're talking about? So this benzene reading, that was from, like just this benzene, that was for our, let's say, 7.9 or 7 point something. Okay. Sorry, 6. Oh, I made a mistake here. This is actually 7. This is 7. This is like I did some mistake here. So this should be yeah, this should be the case. That's the case. So 6, 7. So it is actually in this region. So 6.9. Okay. So 6.9. So 6.9 is the region. So that benzene is for the 6.9. Then we have this 5.5. So 5. Like this is for benzene ring. I'm running the benzene ring again. And 5.5 is for our phenol group, I mean the OH group, and the 3.8 is for our CH3O group. Okay, I mean, yeah, CH3 single bond O group. Okay, this is our structure. Okay, if you didn't get it, rewind the video, rewatch it, and try it by yourself. If still you didn't get it, like give a comment, and I will be explaining it in a different separate video, trying to explain it in further details. Okay. Take care and solve it, because we are done with our HNMR. In our next videos, we'll be moving on to the CNMR, carbon NMR. Okay, take care. Assalamu alaikum.